Just let's see for a minute more, others to join, then we'll continue the class. Okay. So fine. All of these days we have been learning the tricks of addition and subtraction in the past 4 sessions. So since addition and subtraction are the very basic operations, we have a limited tricks over it. But multiplication is a wide sector which has a lot of tricks with it. So let's see a few of it, not a few of it, only one trick for today, because that itself has many cases in it. So let's see that one particular. So we will continue a group of multiplication tricks in upcoming sessions also. As you know, addition and subtraction, when you see, the preferably the most easiest one, which I generally, in the classes also I told you, which I generally ask the children to use it. When it is a lot of borrowing subtraction with the minimum with many zeros, all from 9, last from 10 is the easiest one. That is the easiest subtraction, one thing. Second thing, subtraction from left to right is the most easiest for any category of subtractions. And when coming to additions, I prefer left to right addition is the most easiest one. Or zero ending additions is again easiest, depending on the numbers that you get. So as what all the possible cases are there, I am teaching you, but I suggest you to prefer the one which suits you and which makes you solve the things in the very least. Okay.
Ma'am, the left to right addition and subtraction is the easiest.
Yes, that is the most easiest. But generally, we are being taught from our what is that, from the milk tooth. We have been always taught addition and subtraction from the right side. Do it reversely, do it reversely. No, never do it reversely. As you write from left to right, do the addition and subtraction also left to right. That is the most easiest. So now we will start with the multiplication part 1. As I told you, there are many parts in multiplication, many tricks, but the one which I'm going to teach you will be the only one trick for today's class. And that trick is when we are multiplying two numbers and one of the number is all with 9s. Like it may be with 9, it may be with 99, or it may be with 999, or it may be with 6 9s, 7 9s, whatever it is. When one of the two numbers we are multiplying is all of 9s. Okay. And one important thing that I would like to tell before I state up the cases is, you know that when you are multiplying two numbers, we always call one of it as a multiplicand, the other as a multiplier, right? Since you are in higher classes, you call both as the factors of the product. That is a secondary thing. But the basic terms that we call is, like if I'm multiplying a number, anything of this sort, 679 into 9999. If I'm multiplying like this, one of this is a multiplicand and one of this is a multiplier. But throughout this session, I want you always take the number which is all of 9s as a multiplier always. And the other number would be your multiplier. Fine. We know that 9999 into 679 is also again the same. But whenever you have any way of this question, the 9's number will be your multiplier and the other one will be your multiplier. Fine. This way you need to remember throughout the session. Then we can solve the problems easily. And the other thing is, the speciality of this trick is, even after we are solving the multiplication problems, this doesn't need any additions, lengthy additions, and this doesn't need, basically, without doing multiplication, we can do the product. Okay, we don't need any multiplication for finding the products. And we don't need any bigger subtractions also for the products. Simple subtractions and simple additions are enough to do this. The first case in this is when both the multiplicand and multiplier are having same number of digits. The second case is when the multiplicand has less number of digits than that of the multiplier. Third case is when the multiplicand has more number of digits than the multiplier. Clear? Let's see these three cases for the day. First of all, these type of multiplications are completely time taking in conventional method. The reason they have, first thing is you need to multiply each and every digit of the multiplicand with 9, where you get a carry forward. Again, when you have 3 rows or 4 rows of values, again you need to add them. There again there is carry forward. So there are multiplication operations and bigger addition operations with lot of carryover, which is leading you for time. We will remove this part only. Wherever the carry forward it is, that will, wherever the multiplication is, that also we will do. We will follow one simple trick for it. And what is the trick? Is the magic rule called 1 less than 1 before. What is the magic rule over here? 1 less than 1 before. And what does this rule say? This rule
Ma'am,
says
this
that
magic rule is used for the first case.
for all the cases.
Okay, ma'am.
So this, but there will be a slight change in the magic rule for the last case, but the remaining 2 cases we use the same thing. Like the meaning of this is we need to less 1 from the multiplicand. This means 1 less than the existing value. Whose existing value? We are reducing the multiplicand by 1 to get the product. Okay, as I've told you, what is a multiplicand in this type of questions? All 9s, the number which has all 9s will be the multiplier. The other number would be the multiplicand. The other number which you have, that you should reduce by 1. That means you are finding its predecessor. That's it. I don't think it would be a big difficult thing. Predecessor is a simple thing. However, the big number it is. Correct?
Ma'am, I didn't understand the magic rule.
Yes, ma'am.
Magic-
Even me.
The magic rule is nothing but 1 less than 1 before. 1 less than 1 before means which is already existing. From that, you should reduce 1. That I will show you by a formula. I'll show you
I
that.
have a question.
Yes, please.
So it's basically like example you have 5432 and you want to multiply it by 999. You just multiply it by 1000 and then minus 5432.
Yeah, that way you do it. But again, there you have a lot of subtraction. Yes, I come to your point. Fine. If you want to multiply 5432, so was that your question? 5432. When you want to multiply with 4 9s, what will you do? You will just 54320000 you will write. Then again 5432 you just subtract from it. Whatever it is. From here it starts 543. Isn't it?
Yeah.
Again, isn't that a bigger subtraction?
Yes, ma'am.
Of course. By doing the left to right subtraction, it hardly takes 10 seconds, you think. Fine, I accept it. But the rule which I'm going to show you, you can make it in less than 5 to 6 seconds.
Okay.
You can use this logic. This is the next conventional method which you are doing, and by left to right subtraction, you can do it. Well and good. But this one will still take you lesser time.
Okay.
So here is a method. And before starting up this method, I would like to always make you remember one point. Now, for example, if I have a number, whatever it is, just now you said 543, whatever it is, 543. If I'm multiplying with 9, the same 543 if I'm multiplying with 99. The same 543 if I'm multiplying with 999. In all these cases, I've told you, the bases are the magic numbers which doesn't leave Vedic maths. They come out throughout Vedic maths in some other way. So here also we use the base numbers, and the base numbers are always considered with respect to the multipliers only. In all these cases, the multiplicand is same. So I can't say the base is 1000 here because it is a 3-digit number, which is incorrect. In the first case, the base is 10 because I have only 1 digit in the multiplier. In the second case, the base is 100 because I have 2 digits in the multiplier. The third case, the base is 1000 because I have 3 digits in the multiplier. So throughout this method of multiplying with 9 forms, we always need to remember we should consider the base in the problem basing on the multipliers only, but never using the multiplicands. These 2 logics you want to do. One thing, that you are taking up the 9 forms as a multiplier always, and the base also should be considered depending on the multiplier only. The other number is the multiplier. These 2 points, if you remember, you can understand this very easily. Clear, children, so far? So what is the rule says? The first case, when the number of digits of both multiplicand and multiplier are same. That means if you have 3-digit numbers in the multiplicand, multiplier is also 3 digits. Let us see. What is the rule is? The product will have two parts. One is the left side, the other is the right side. Left side is multiplicand minus 1. This is what the magic rule is. Predecessor of the multiplicand will be the left side of the answer, and the right side of the answer is base minus multiplicand. What is it? Base minus multiplicand. So always, just now I told you, the value of the base changes depending on the multiplier only. However, we are subtracting multiplicand, but the base is taken with respect to the multiplier. Clear? This is the only one step that you need to apply. Let me show you with an example. 358, I am multiplying with 999. So this is a 3-digit number, that is also 3-digit. Then what would be the base in this case?
1000.
Perfect. So these are 3 nines, so the base is 1000. So here the base is 1000 and the multiplier is 999. So how are we going to multiply this? Let us. You don't need to do any multiplication. 358, you just reduce by 1, it becomes 357. And the right side part, 1000 minus 358. So is 1000 minus 358 a bigger thing? No. Why? Because what is our magic rule we have with us?
Ma'am, all from 9 and
Nikhil,
last from 10.
Yes,
Ma'am,
all
all from 9 and last
from
from 10.
So that is a simple magic rule which makes you tell this orally. Left part, left side is oral value because 1 you are reducing. Right part is also oral part because you are just doing all from 9, last from 10. So how much time does this complete calculation need? Tell me.
Ma'am, 5 to 6 seconds.
Since it is a 3-digit number.
Ma'am,
In this method,
this is
you
how
can
we get it.
Yes, this is how we get it.
Ma'am, so what if the number is like the multiplier is like some digit which is like 18 or something like that?
No, that rule cannot be applied. This rule is applied only when the multiplier is all 9s. Okay. Further, different rules are there. That also I'll teach you in the ahead classes. As I've told you, multiplication has so many tricks. We will learn ahead one after the other. The very first class, let's start with 9 forms. So am I clear so far, children? Any doubt? Please unmute to speak.
Ma'am, no doubt.
Okay, dear. So let's see some more examples. Here again we have. This logic can be used for however the bigger number it is. Either it may be 8 nines, 9 nines, 6 nines, any number of bigger numbers you can easily solve with this trick. Like here it's a 6-digit number. Multiplicand is also having 6 digits. Multiplier is also having 6 digits. Anyone who can give me this answer? I just placed a small trick in the number.
Ma'am, can
Let
I?
me see who could observe it.
Ma'am,
Okay,
can
fine.
I?
Yes, Pratik, tell me.
706,019,
Okay.
then 2939
Mhm.
7. Sorry,
Ma'am,
2939. Then will be minus 10 minus 2, 8. 293980.
Very good. Now you are right. Yes. Who was the other one who want to give the answer for this? Let me show you. So here, what we did is multiplier is 6 zeros. So we took 1 followed by 6 zeros. Now the left side will be 1 less than the multiplicand. So 706019. That would be the simple part. And in the right side, I've told you, whenever you have a zero ending numbers, how to subtract. Do you remember that?
we
Even
need to
after-
carry forward the one.
Yeah, you can do the carry forward one, or you can remove the extra zeros at the end and you can solve it. Again, I'll recall you that for you. So 1000. Like if I want to subtract 1000 and 840 from this, one method of doing is both are ending in zeros. This extra zero first I'll put out in the answer. Now for 184, I will apply the all from 9 last from 10, which is 16. This way.
Ma'am,
Or
160.
the other one. Or the other method is you can directly apply the rule which is it? 1, 6, and this part would become 10. But there should be only one digit. So this 1 you carry forward here. I mean, sorry, before it was, what was that? 5. Sorry. So this 1, when you carry forward here, it becomes 160. However you do the subtraction. So I just want to see to what extent you remember the trick. So I gave a 0 at the ending. So fine. 706019293980. So that would be your final answer. So now tell me, this regular bigger number, even by doing the subtraction method, somebody asked me initially, man, why can't we just make it as a full number and subtract the multiplicand? That way also you can do. But for bigger numbers, subtraction is again time taking. Isn't that completely reduced over here?
Yes, ma'am.
Yes. Now we will see the same over for decimals. So how can we do it for decimals?
We will remove the decimal point
Perfect.
and again put that.
Yes, perfectly said. Just remove the decimal points, solve them as numbers, then apply the decimal. Okay, so here I will make this number as with decimal forms without using the decimal point, like 4701 into 9999. Now this solving is very easy for me. Yes. So how will I solve this? Here there are 4 nines. So my base would become, what is that? 10,000. 1 followed by 4 zeros. Now, how will I multiply this? This 4701 will be reduced by 1 on the left side. And on the right side, 4701 would be reduced from 10,000. So which is again an oral answer, 47005299. This is the answer for the numbers which are multiplied by removing the decimal point. Now, how do we put the decimal point in these cases? There are 3 digits.
Ma'am, there are 3 digits on the first one and 2
Two
digits on the
digits.
second one.
Yes.
So we have to like skip 5 numbers
5
and then put the
digits. From
decimal.
the right side, you need to move to the left side and put decimal point after the 5 digits.
So
in the
ma'am, it
product.
will be 470.05299.
Yes, perfectly said. So that is how you get the answer. So now tell me, is this trick of multiplication with 9 useful?
Yes, ma'am.
However, the bigger the number it is, you can just multiply it. You can give out the oral answer. If you have a proper practice, just by looking at the numbers, you can just answer it oral. Clear so far, children?
Yes, ma'am.
Now let's move on to the practice questions. Let me start with one by one. Arav, can you answer this question? Sorry, Arnav. Arav is also there in the class. Okay, sorry, dear. Arav, I'll come back to you. Arnav, answer this.
Yes, ma'am.
Ma'am,
Just give me
6-4.
the answer in
Ma'am,
the form of digits.
64113588.
Just give me the answer in the form of digits, because if you don't give it in digits, reading out the numbers would be difficult. Yes,
Ma'am, 64113588.
64113598.
88.
Okay, 88. Yes, perfectly correct.
Yes, ma'am.
So, Arav, sorry, not Arav, Arnav. What's your answer, dear?
Yes, ma'am.
So let's go on to the next question. There are correct answers in the chat box. Very good. Viraj, Pratik, Suman. Perfect. All your answers are perfectly correct. Very good. So please, others also give the answers in the chat box. And here is the next question. Arav, here is a question for you.
Okay.
Please do not sit idle. Either work out or give the answers in the chat box. Just by looking at the screens as if you are looking into a movie makes no sense.
Ma'am,
Yes.
is it 5059949400?
Come again. 505994. What did you say? 4 after?
4940.
494.
Yes, 49400. Yes, perfectly correct. That is the answer.
Ma'am, I joined a bit late, so I don't know how to do. Can you do only one sum and show me?
Yeah, dear, for sure, definitely. Just give me a minute. I'll show the next question. They have answered this question. So, yes, perfectly correct answers in the chat box. Pratik, Shaurya, Arnav. Arnav, please do not put commas. It becomes confusing for you to read and for me also. So, it's just a number. Read them as digits. Bigger numbers and never need to be read as numbers. Viraj is also correct. Suman is also correct. Perfect. Please, others in the class, give the answers in the chat box. Fine. Here is the next question. Shaurya, can you solve this question?
Yes, ma'am. Let me just
Yes. Moshika, please look at the question. So when we have
Ma'am.
numbers of this sort, here we are talking about the concept of multiplication with numbers which has one of the number as all nines, like 523 into 9 or 5342 into 99, whatever it is. One of the numbers should be all with 9 zone. Either it may be 9, 99, 999, whatever it is.
Okay, ma'am.
In this type of multiplication, you need to always remember we should take the base basing on the multiplier only. The base will be on the
Okay.
multiplier. In this case, the base would be 10 because there is only one
Yeah.
digit in the multiplier. In this
100
case,
over
the
there.
base would be 100. And in this case, the base would be 1 followed by 5 zeros. That way. These two
Okay,
points
ma'am.
you need to remember first. All 9 forms will be the multiplier. And the base would be basing on the multiplier only. Now,
Okay, ma'am.
when we are multiplying two numbers which are having same number of digits, 4 digits, 4 digits, 5 digits, 5 digits, that way. When we are multiplying two numbers with same digits, the product rule is nothing but multiplicand minus 1 will be the left part of the answer, and the right part of the answer would be base minus multiplicand.
Okay, ma'am. Okay, ma'am.
That's it. These two parts, if you put together, that would be your answer. Where you don't need any multiplication tables, you don't need to remember any multiplications, you don't need to do any bigger addition subtractions. This you can easily do because base minus multiplicand is all from 9, last from 10. And this is just a predictor of the number. So it is pretty easy.
Okay, ma'am.
Ma'am, can you explain me this decimal question?
Yeah, dear, sure. So this decimal question also we will do in the same way. 894 will be the number, 999 will be the number.
Yes, ma'am. So then the base
894
will
if
be
you reduce by 1,
1000.
893.
Yes, ma'am.
And this would be the base would be 1000.
1000.
9 minus 8, 1, 9 minus 9, 0, 10 minus 4, 6.
Okay, ma'am. So, ma'am, we don't have to count the zeros like the
No.
it's 0.
Our just number, we are just in need of numbers. Digits are needed for us.
Okay, ma'am.
Base, decimals you remove it. When you remove the decimals, left side result doesn't matter, isn't it? So
No,
1,
ma'am.
2, 3, 4, 5, 6, 7. So 7 digits before that, you just need to place the decimal.
Now I send the answer in chat. Is that
Yeah,
correct?
dear, I'm looking at Shaurya. Answer, please, dear.
Yes, ma'am. Is the answer 0.893106?
0.89. No, 0.08.
And why is that?
We have 7 decimal places here overall, isn't it?
Yes, ma'am.
So we need to put one more. You just got 6 digits in
Okay,
our
ma'am.
product. Yes,
Okay,
that
ma'am.
is right. Yes. So the answers in the chat box are correct. Let me just give out the other question. Oh God. Fine. Here is a question. Pratik, solve the question on the screen.
4
So the before third question.
702.
Yes, continue, Pratik.
I will solve the fourth question.
Yeah, you should solve the fourth question.
1, 2, 3, 4, 5, 6, 7, 1, 2, 3. 4270208 5729791.
1. Yes. And the decimal would be?
Oh, the decimal.
Just tell me the position. That's enough. You gave me all the correct digits.
Last 4.
Yes, perfectly said. So that is the correct answer. So yes, all the answers in the chat box are perfectly correct for the third question. Pratik, Viraj, Guntas, Kaustubh, Nidhi, Viraj, Nagarajan, all your answers are correct, children. Gauri, Suman, very good, very good. Very good to see the children who has given first time answers in the chat box also. Very good. So perfectly right. Very good attempt. Good. Yes, even this question answers are also correct. So good. There I have received all the correct answers in the chat box. Very nice to see. So do you think such a bigger number, do we need a pen and paper to solve it? I don't think so. You can just give out orally. How many of you are using pen and paper to solve these questions? Please raise your hand. It's not that a 10th class child doesn't need a pen and a 7th class child need a pen. No, the numbers are very simple. You are no way in need of reading the numbers. You are just putting the digits together. However, the big number this is, you just need to write all these digits same, only the last digit reduced by 1. And again, all from 9, last from 10. 5, 7, 2, 9, 7, 9, 1. It's again easy. So I preferably say, try to give it orally. Orally in the sense you can write the value on the paper, not using the calculation part by steps. So fine. That was the first case. Let's do the second case. The second
Ma'am,
case
can you
is,
please explain that last part?
which last part here? Last question.
No, yes, ma'am. Fourth.
Yeah. Okay, keep yourself unmuted, Kaustubh.
Yes, ma'am.
Tell me the left side of the answer.
Ma'am, it is 420208.
420.
Four,
This is a
sorry, ma'am.
multiplicand.
Sorry, ma'am.
This is a multiplicand.
4270208.
420208.
208. This is the left part, right? Now right part. What is the right part? You need to subtract from the base. Subtract from the base means all from 9, last from 10. So subtract all from 9 and only the last digit from the 10. So all from 9, you do it. What do you get? 5, 7, 2, 9, 7, 9. And the last digit from 10, when you subtract, you get 1. Kaustubh, are you there?
Yes, ma'am.
Understood how did I get this part?
Yes, ma'am.
Yes. Now this is my complete answer. In this complete answer, there are only 4 decimal places. So after the 4 decimal places from the right side, I'll just put it on. So see, 4270208. This is the remaining and 572.9791.
Okay, ma'am.
The next case is when the multiplicand has less digits. So do you remember what did we do when the subtrahend has less digits in non